Wanted to work through some conceptual questions on the topic of electrical charge and the properties of electrical charge. I've got a list of questions here, 4 questions. I'm just going to work through them. I'm going to explain them in words. Maybe I'll write something down. Maybe I'll draw a figure, but basically explaining my understanding of these questions in words. So first question. An object acquires a positive charge by rubbing. In the rubbing, have protons, which have positive charge, been added to the object, or have electrons, which have negative charges, been removed to the object? So when we charge, do we move electrons around? Do we move protons around? Do we move both around, depending on the charge? The answer is we always move electrons around. We never move protons around in charging by rubbing. Electrons are light, weakly bound, mobile particles. They're easy to move around by rubbing. Protons are heavy, strongly bound, immobile particles. They're not moved around by rubbing. So whether you create a positive charge or negative charge of an object by rubbing, you're always creating that positive or negative charge by moving electrons. If it becomes negative, it's acquired excess of electrons. If it's positive, it's got a deficit of electrons. Why do hospital workers, when they're working around oxygen equipment and they're working around oxygen gas, why do they wear conducting shoes, not insulating rubber shoes? Let me talk about some background information that's useful to this problem. Background information that will help us understand this problem. First piece of background information is about the Earth. The Earth is a big sphere, massive sphere, and it's a massive conducting sphere. So the Earth is a conductor. If we were to place a positively charged object onto the Earth in electrical contact with the Earth, then electrons would flow out of the Earth to neutralize that object. If we were to place a negatively charged object on the Earth in electrical contact with the Earth, then electrons from that object would stream into the Earth. So the Earth acts as a reservoir of electrons. It will neutralize a positive object if you place it on the Earth. Acts also as a reservoir if you place a negatively charged object on the Earth. The excess electrons will stream off into the Earth. So the Earth's so big, it can give a positive object all the electrons it needs to neutralize it, as long as it's in contact with the Earth. It can receive from a negative object as many electrons as needed to neutralize that object into the Earth. In a hospital, you want to be in electrical contact with the Earth if you're working near oxygen equipment. If you're in electrical contact with the Earth by wearing conducting shoes, then if you acquire by rubbing or touching some excess negative charge, that charge will flow into the Earth. If you acquire by touching or rubbing some excess positive charge, then electrons will flow up from the Earth and neutralize that. So if you're in electrical contact with the Earth with conducting shoes, then you will never become charged. You'll always stay neutral, and you won't spark and create a fire, an explosion in the oxygen environment. If you wear rubber shoes, that insulates you from the Earth. So if you touch something or rub something, then you can acquire a positive charge and it won't get discharged by the Earth. If you touch something or rub something and you become negatively charged, it won't get discharged because you're not in electrical contact with the Earth because of your rubber shoes. So if you're wearing rubber shoes and working around oxygen in a hospital, you can acquire a positive charge, you can acquire a negative charge, and therefore you can spark and you can create a fire and an explosion. So that's why you wear conducting shoes around oxygen equipment. You don't wear rubber shoes around oxygen equipment. Would life be different if electrons were actually positively charged, not negatively charged, and protons were actually negatively charged, not positive charged? Would life be different? Would life in any way be different? No. No, life would not be different. It wouldn't be different in any way. The fact that we call electrons negatively charged and protons positively charged is just a convention. It's just a consensus. It's just an agreement among us. We could have called electrons positively charged and protons negatively charged, and all the same phenomena, all the same effects would arise. For example, if we reverse the charges of the electrons and protons, we made the electrons positive, we made the protons negative. Still, two protons would repel one another because they're two like negative charges. Two electrons would repel one another because they're like positive charges. And an electron and a proton would attract one another. So changing electrons from negative to positive, changing protons from positive to negative, if we do both of those things, we make no change in the world whatsoever. And it's not just true about electrical attraction, electrical repulsion, things we've met so far. It's true about every other effect, every other phenomena in electromagnetism. Nothing would be changed in electromagnetism if we just change the consensus, if we just change the agreement that electrons are negative and protons are positive. So electrostatic demonstrations in a general physics class. So the demonstrations with plastic glass rods and cat's fur and silk, and rubbing the glass and plastic rods with the fur and the silk. They work well, relatively well, on dry days. They don't work well on humid, wet days. Why? So why is that? The answer to that is the properties of the air. So on a dry day, what we mean is that the air contains small amount of water vapor. Whereas on a wet, humid day, what we mean by that is that the air contains a much larger amount of water vapor. So humid air is air with lots of water vapor. And dry air is air with very little water vapor. The amount of water vapor in the air affects the conductivity of the air. So dry air is like a good insulator, and charge can't flow through the dry air. And so charge can build up on a plastic rod or a glass rod and not discharge through the air. Humid air, wet air, on the other hand, that's like a conductor. If we charge up a plastic rod or a glass rod in humid air, that plastic rod, that glass rod can discharge through the surrounding conducting humid air. So humid, wet air affects experiments, electrostatic demonstrations, because it allows the charge that we build up for the demonstration to discharge through the air. Dry air, on the other hand, doesn't allow the charge that we built up in the electrostatic demonstration to discharge. And so in dry air, those demonstrations work well. Well, these were a few examples of electrical charge involving the ideas of electrical charge, positive and negative charges of electrons and protons, involving the ideas of conductors and insulators and the properties of conductors and insulators, involving ideas of rubbing and charging and how that works, involving ideas of discharging through insulating or conducting media. And so it gives us some experience, some practice with the concepts of electrical charge and the properties of electrical charge.